NASA says its Voyager 1 probe is sending usable information to Earth again, raising the possibility of aliens enslaving us in the vast, silent darkness of space. Voyager 1's silence has been broken. The probe has received a signal, an unexpected intelligent reply from an unknown object. This isn't a malfunction or cosmic noise. It's a direct communication from the abyss of interstellar space. What or who is out there? How did Voyager 1 suddenly receive an alarming reply from a nearby object in space? Voyager 1, breaking beyond the solar system on September 5, 1977, marked a monumental moment in space exploration. The world witnessed the launch of Voyager 1 from NASA's Kennedy Space Center at Cape Canaveral, Florida, aboard a Titan Centaur rocket. The spacecraft embarked on a mission that would stretch far beyond its initial goals, breaking through the confines of our solar system. Though its twin, Voyager 2, had been launched 16 days earlier on August 20th, Voyager 1's faster trajectory propelled it into space, setting the stage for one of the most remarkable explorations in human history. Voyager 1's primary mission was to explore the gas giants, Jupiter and Saturn, a task it performed with spectacular success. On March 5, 1979, it made its closest approach to Jupiter, capturing stunning images and data. While Voyager 2 continued its journey to Uranus and Neptune, Voyager 1 took a different path. After its close flyby of Saturn's largest moon, Titan, the spacecraft was catapulted out of the plane where most planets orbit the Sun. Voyager 1 began its epic journey toward interstellar space, continuing to send back data as it sailed ever farther from the Sun. Years passed, and Voyager 1 remained active, defying expectations. On August 25, 2012, it crossed the heliopause, the boundary where the Sun's influence wanes and the vastness of interstellar space begins, making it the first human-made object to enter this unexplored region. This milestone marked a new chapter in its voyage as it began to study the space between the stars, revealing data that scientists had never before been able to collect. Voyager 1 continues to travel outward at a staggering speed of approximately 520 million kilometers per year, sending back whispers of information from the distant reaches of space. It now moves at an angle of 35 degrees above the plane of the planets. Voyager 1's journey is far from over. While its instruments will eventually run out of power, the spacecraft itself will continue its silent drift through interstellar space, perhaps for billions of years. Its mission, now part of the Voyager interstellar mission, embodies humanity's thirst for exploration, pushing the boundaries of what we know about the cosmos. The Voyager missions have given us unmatched understanding of our solar system and the space beyond. These incredible spacecraft have been hard at work, helping us learn how the solar wind, charged particles constantly flowing from the Sun, interacts with the vast expanse of interstellar space. The data from Voyager has also provided key insights into the heliosphere, a giant bubble of charged particles that surrounds and protects our solar system, shaped by the forces of the space beyond. NASA scientists have even combined Voyager's findings with newer missions to piece together a fuller picture of the Sun and how it influences the space around us. This information has been crucial in deepening our knowledge of the boundaries of our solar system and the unknown regions beyond. When we think about Voyager 1's incredible endurance, its resilience truly stands out. A machine traveling through the harshest environment possible, outer space, where it encounters intense radiation, extreme temperatures that either freeze or burn, and tiny space debris moving at incredible speeds. Despite these challenges, Voyager 1 has persevered for an astonishing 47 years. This remarkable longevity is due in large part to its exceptional design, a true testament to the brilliance of the engineers and officials who created it. Voyager 1 was built to withstand cosmic radiation, while temperature fluctuations, and constant impacts from space debris. What makes it even more remarkable is its power source, nuclear batteries known as radioisotope thermoelectric generators, or RTGs. These generators produce electricity by converting the heat from the natural decay of plutonium-238 into electrical energy. The key to this process is a device called a thermocouple. Thermocouples are actually something we use in our everyday lives in things like air conditioners, refrigerators, and medical thermometers. They work based on a simple principle. Two metal plates, each made from different materials that conduct electricity, are connected to form a closed circuit. When one of these metal junctions is kept hotter than the other, an electric current is produced. In an RTG, the heat from the plutonium-238 warms one of the metal plates, while the other stays cooler thanks to the coldness of space or a planetary atmosphere. This temperature difference creates a steady flow of electricity that powers the spacecraft, making RTGs a dependable source of power for long space missions. Although Voyager 1's RTG energy output has gradually decreased over time, it still generates enough power to keep its scientific instruments operational. Voyager 1 is not only durable, but also highly intelligent. It carries a suite of sophisticated instruments, much like a scientific toolkit in space. On board are devices such as the Cosmic Ray Subsystem, a high-gain antenna, an imaging science subsystem, a magnetometer, and a plasma wave subsystem. These instruments have played a vital role in uncovering many of the solar system's mysteries. Voyager 1 has collected stunning data on Jupiter's powerful winds and storm systems and even discovered active volcanoes on its moon, Io. Its study of Saturn revealed that the planet's rings, far from being simple, are filled with fascinating structures, including ringlets, twists, and spokes. Beyond the visual discoveries, these instruments have been invaluable in studying cosmic rays, analyzing charged particles, investigating magnetic fields, and detecting plasma waves. As Voyager 1 sped through the vastness of space, it carried a remarkable treasure, a message from Earth meant for any unknown beings it might someday meet. This precious item, called the Golden Record, is humanity's way of reaching out across the stars. The Golden Record is a 12-inch gold-plated copper disc filled with sounds and images chosen to showcase the richness of life and culture on our planet. It's like a time capsule from Earth, telling the story of who we are and where we come from, hoping to connect with any intelligent life forms that might find it. The disc holds 116 images and a variety of sounds. It includes the melodies of our music, greetings in 55 different languages from around the world, and the natural sounds of thunder, birdsong, and whale calls. Each piece was carefully selected by a team led by the famous astrophysicist Carl Sagan to represent Earth's diverse cultures and experiences. Both Voyager 1 and its twin, Voyager 2, carry this special message. It's amazing to imagine that these spacecraft might one day be found by extraterrestrial beings. If an advanced alien civilization were to discover Voyager 1 and the Golden Record, it could lead to a groundbreaking moment in our history of reaching out to other worlds. Here are 3 intriguing possibilities for what might happen. First, the aliens could try to understand the Golden Record, using their advanced technology to interpret the images and sounds. Second, if they can travel across space or communicate over long distances, they might send a response that could reach Earth by 2029. It's no surprise that scientists think we might make our first contact with extraterrestrials as soon as 2029. Third, they might choose to study Voyager 1 without making contact, following the idea of not interfering with other civilizations, an idea often explored in science fiction. Regardless of what happens, any contact with extraterrestrial life would be a monumental event, changing our understanding of our place in the universe. Voyager 1, after many years of faithful service, has recently sparked a new wave of curiosity with its latest findings. The spacecraft has started sending back puzzling data from the edge of interstellar space, leaving NASA engineers scratching their heads. The trouble seems to come from an important part of Voyager 1 called the Attitude Articulation and Control System. The Attitude and Articulation Control Subsystem, or ACS, is like the spacecraft's steering and balance system. It makes sure the spacecraft stays pointed in the right direction, especially keeping its big antenna aimed at Earth so we can keep receiving data. It also helps the spacecraft turn and adjust its position as needed, plus it carefully positions the scan platform to ensure everything is lined up perfectly for taking those important space pictures and measurements. Strangely, the data from Voyager 1's ACS is now inconsistent with the spacecraft's actual movements and orientation. It's almost as if the spacecraft has lost its sense of direction in the vast expanse of space. Despite this odd behavior, NASA assures us that Voyager 1 is still performing its duties well. It continues to receive commands from Earth and gather valuable scientific information from its far-off location. The spacecraft doesn't seem to be affected by this glitch. Its onboard safety systems haven't been triggered, meaning Voyager 1 hasn't gone into protective mode. Interestingly, its communication signal remains strong, and the high-gain antenna is still correctly aimed at Earth. However, the data from the AACS appears random or illogical at times, deepening the mystery. Suzanne Dodd, the project manager for both Voyager 1 and Voyager 2, explains that such mysteries are to be expected given the age of these spacecraft. Voyager 1 and its twin have traveled farther and lasted longer than anyone could have imagined. Now, as they journey through the harsh, high-radiation environment of interstellar space, an area no spacecraft has explored before, some quirks and mysteries are bound to arise. Although the engineering team at NASA is struggling with a significant challenge, they remain optimistic about resolving the issue with the spacecraft's ACS. This situation is similar to an obstacle Voyager 1 faced in 2017 when its primary thrusters began showing signs of wear. Back then, the engineers had to activate thrusters that had lain dormant for 37 years, a move that successfully kept the mission alive and operational. The current twist in the tale is that NASA's ingenious engineers have pinpointed the source of the problem. It turns out that the ACS was sending telemetry data to a computer that had long since failed, resulting in corrupted data. The project manager, suspecting this malfunction, took a strategic gamble by repeatedly commanding the AACS to redirect data to the correct functional computer. Although the exact cause of the AACS's misdirection remains unclear, a malfunction in another onboard computer might likely have triggered this issue. This suggests that there could be a broader underlying problem within the spacecraft. Nevertheless, the engineering team believes that this doesn't pose a serious threat to Voyager's overall mission health. As the team works to unravel these technical mysteries, they are also eager to deepen their understanding of Voyager 1's complex systems. It's important to recognize, however, that Voyager 1's journey through the cosmos is finite. The spacecraft's mission will eventually come to an end, raising an intriguing question. How long can Voyager continue its remarkable journey through the vast expanse of space? To answer this, we need to grasp how Voyager 1 manages to communicate with us from a breathtaking distance of 24 billion kilometers and understand the factors that will determine how long we can maintain contact with this extraordinary explorer. Voyager 1's continued communication with us relies on a carefully engineered radio system designed to function both within and beyond our solar system. Central to this system is a powerful high-gain antenna, which is essential for sending and receiving radio signals. This antenna interacts with 3 Earth-based stations that form the Deep Space Network. The Deep Space Network, or DSN for short, stands as a testament to human ingenuity and perseverance, bridging the vast distances between Earth and the farthest reaches of our solar system. Managed by NASA's Jet Propulsion Laboratory, the DSN is not just a network of massive antennas. It's a beacon of humanity's quest to explore the unknown. Its primary mission is to communicate with spacecraft traversing deep space, including the iconic Voyager 1, which continues its historic journey far beyond the bounds of our solar system. The DSN consists of 3 major facilities, each positioned strategically around the globe: Goldstone in California, Madrid in Spain, and Canberra in Australia. This global arrangement ensures that no matter where Voyager 1 is in its orbit, there is always a DSN station ready to maintain contact. The Deep Space Network, DSN, is able to maintain contact with Voyager 1 as Earth rotates, ensuring the spacecraft never loses communication thanks to this meticulously planned network. Each of these sites is equipped with large, highly sensitive antennas capable of picking up even the faintest signals from the farthest reaches of space. Voyager 1 communicates with the DSN using its low-power radio transmitter, sending data back to Earth at a rate that seems almost infinitesimal by today's standards, just 160 bits per second. This slow data rate is a result of the vast distance between Voyager 1 and Earth. At over 14 billion miles away, the signal is incredibly weak by the time it reaches us. However, the DSN's antennas are designed to detect these nearly imperceptible signals. Each antenna is a massive parabolic dish, sometimes over 70 meters, 230 feet, in diameter, carefully engineered to focus and amplify these faint radio signals. To achieve this, the DSN employs advanced technology to reduce the challenges of deep space communication. The antennas are equipped with highly sensitive receivers and sophisticated amplifiers, which are cooled to just above absolute zero to reduce noise and interference. This is crucial because the radio signals from Voyager 1 are easily overshadowed by the natural radio noise from celestial bodies and electronic interference from Earth itself. The DSN's engineers use a range of techniques to filter out this noise and extract the valuable data sent by Voyager 1. Each DSN site is equipped with a signal processing center where the incoming signals are processed and analyzed. The data is then transmitted to NASA's Jet Propulsion Laboratory, JPL, for further analysis and distribution. This process is vital for interpreting the scientific information sent back by Voyager 1, which includes images and data on the outer reaches of our solar system and beyond. The information collected helps scientists understand more about the heliosphere and the interstellar medium that lies beyond it. Voyager 1's mission represents a monumental achievement in space exploration, and the DSN plays an indispensable role in this journey. The network has been crucial in maintaining contact with Voyager 1 as it passes through the boundary of our solar system and into interstellar space. Each signal received from Voyager 1 is a piece of history, a snapshot of the spacecraft's voyage through regions of space humanity has never before seen. In addition to supporting Voyager 1, the DSN continues to be a pivotal component of numerous other space missions. Its capabilities extend beyond communication, providing essential radar and radio astronomy observations that enhance our understanding of the universe. As NASA looks to the future, the DSN will play a central role in the Artemis missions, which aim to return humans to the Moon and eventually send astronauts to Mars. As Voyager 1 journeys into deep space, it has become increasingly difficult to communicate directly with Earth. To manage this, the spacecraft uses a digital tape recorder that can store about 67 megabytes of data. This allows Voyager 1 to save its data and send it back to Earth when communication conditions improve. As of 2023, it takes over 22 hours for signals from Voyager 1 to reach Earth, compared to the 15 minutes it takes for data from Mars rovers. Another challenge is the weakening of Voyager 1's signal as it travels farther from Earth. The spacecraft sends data using a weak 20-watt signal, which becomes much fainter over its long journey through space. Despite this, the real issue isn't the signal's strength, but having a sensitive receiver to detect it. Thanks to the DSN, this isn't a major issue. However, every day, Voyager 1 drifts farther into the great expanse of space, a lone messenger on an endless journey. As it moves away from Earth, keeping in touch becomes more difficult, with the signals from Voyager 1 traveling slower, taking longer to reach us, making communication increasingly challenging. Still, there is no theoretical limit to how far we could continue to talk to this daring explorer. However, reality imposes constraints. Our ability to stay in contact with Voyager 1 is running out of time, and that time is measured in just a few years. Additionally, since Voyager 1 is powered by a nuclear source, its electrical power decreases gradually over time. In 1990, engineers made a crucial decision to save energy by turning off Voyager 1's camera after it took the famous pale blue dot photo, showing Earth as a tiny in the vastness of space. Today, only 5 of the original 11 scientific instruments are still active. To keep these essential tools functioning, engineers have had to make difficult decisions, such as turning off heaters and other components. Despite these challenges, the remaining instruments continue to send back vital data about magnetic fields, solar winds, and cosmic rays, serving as our eyes and ears far beyond the solar system. In 2022, NASA took steps to conserve energy and keep the Voyager missions going beyond 2025. By 2023, the space agency announced even more power-saving measures, extending the life of one of Voyager 1's science instruments until 2026, instead of shutting it down this year. Despite these efforts, more instruments will likely start to fail by 2025 or 2026, although some might keep working until the end of the decade. The end of this remarkable journey is approaching, and by the mid-2020s, we will likely receive the final message from Voyager 1. The Deep Space Network will receive these signals, but even these powerful antennas have limits. NASA estimates that the Voyagers might stay in contact through the Deep Space Network until about 2036, depending on how much power the spacecraft has left. This will mark the end of an era in space exploration as we prepare for our final communication with Voyager 1. However, the big question still lingers. When NASA eventually loses contact with Voyager, how far into the vast expanse of deep space will this remarkable spacecraft journey? Now it's time for today's subscriber pick. In the vast, uncharted regions beyond our solar system, Voyager 1 continued its solitary trek, carrying humanity's message into the void. For decades, it had sent signals and received only the quiet hum of space in return. That is, until one fateful day, when Voyager 1 suddenly received an alarming reply from a nearby object in space. The scientists at Mission Control were initially skeptical when the strange signal began to decode. The message was unlike anything they had encountered. "Help us, we are the last of our kind." The source of the message was a shadowy metallic sphere that had recently been detected orbiting a distant, dying star. This object, previously a mere blip on their radar, was now sending an urgent plea for aid. Voyager 1's systems confirmed the message was artificial, and the object's trajectory suggested it was approaching their probe. The atmosphere in the control room grew tense as the team worked feverishly to understand the implications. Could this signal be a genuine cry for help from an advanced but endangered civilization? Or was it a sophisticated ruse, a trap designed to lure them into a cosmic snare? As the team weighed their options, they faced an unsettling truth. This might be humanity's first direct encounter with extraterrestrial intelligence. But was it a chance for contact, or a dire warning? Voyager 1's future remains uncertain. By September 5, 2027, Voyager 1 will mark a remarkable milestone: 50 years of interstellar travel. This iconic spacecraft has journeyed far beyond the realms of our solar system, blazing a path through the cosmos at an impressive speed of approximately 38,000 miles per hour. At this point, Voyager 1 will be about 176 astronomical units from the Sun, roughly equivalent to 24 light-hours away. This distance underscores the vast scale of space and the remarkable achievement of human engineering and ambition. Yet despite its incredible speed, Voyager 1 is still in the early stages of its interstellar journey. To put this in perspective, if it maintains its current velocity, it will take about 300 years just to reach the inner edge of the Oort cloud, a distant region of icy bodies surrounding our solar system. To encounter another star, Voyager 1 would need to travel for approximately 40,000 years. So where is Voyager 1 headed over the next billion years, and what might it encounter along its journey? Realistically, the spacecraft will face challenges such as micrometeoroid impacts, cosmic radiation, and thermal cycling. These factors may lead to structural degradation over time. However, Voyager 1 could keep drifting for hundreds of millions to even a few billion years, as long as it doesn't crash into anything big. Voyager 1 will continue to traverse the galaxy, potentially passing by numerous stars and constellations such as Hercules, Lyra, Cygnus, Draco, and Camelopardalis. Over billions of years, its trajectory will be influenced by various factors, including gravitational encounters with molecular clouds, passing stars, and the Milky Way's tidal forces. The galaxy will evolve significantly during this time, with stars moving from their current positions and constellations changing shape or disappearing altogether. Predicting Voyager 1's exact path is challenging due to these uncertainties, but its journey embodies the quest for knowledge and discovery. As it travels through the uncharted territories of the universe, Voyager 1 continues to represent humanity's curiosity and drive to explore the unknown, an epic tale of cosmic exploration. Let's take a moment to review some of the incredible achievements of the Voyager spacecraft, Voyager 1 and Voyager 2. Launched in 1977, these twin spacecraft, virtually identical in design, carried a suite of 10 scientific instruments, including television cameras, infrared and ultraviolet sensors, magnetometers, plasma detectors, and cosmic ray and charged particle sensors. Their mission was as ambitious as it was groundbreaking: to explore the outer planets and then venture into interstellar space. Voyager 1's closest encounter with Jupiter occurred on March 5, 1979, when it passed just 349,000 kilometers, 217,000 miles, above the planet's cloud tops. Voyager 1 provided the first detailed images of the gas giant's swirling atmosphere, its turbulent storm systems, and its thin ring system. However, it was the stunning close-ups of Jupiter's moons that truly captivated scientists and the public alike. The probe discovered active volcanoes on Io, an icy crust on Europa that suggested a subsurface ocean, and complex geological features on Ganymede and Callisto. After its historic flyby of Jupiter, Voyager 1 used the planet's gravity to slingshot itself towards Saturn, the next stop on its grand tour of the outer planets. On November 12, 1980, Voyager 1 made its closest approach to Saturn, passing just 124,000 kilometers, 77,000 miles, above the planet's cloud tops. The spacecraft sent back breathtaking images of Saturn's iconic rings, revealing intricate structures, including mysterious spokes and gaps in the rings. Voyager 1 also closely studied the planet's atmosphere, magnetic field, and moons, particularly Titan. Although Voyager 1 couldn't see through Titan's thick, smoggy atmosphere with its optical instruments, its infrared and ultraviolet sensors provided valuable data on Titan's dense, nitrogen-rich atmosphere, which is rich in organic molecules. These findings hinted at the possibility that Titan could harbor prebiotic chemistry or even conditions suitable for life. Following its encounters with Jupiter and Saturn, Voyager 1's trajectory took it out of the plane of the solar system's planets and toward the heliopause, the boundary where the solar wind meets the interstellar medium.